Next up is Belhorma from Spotify, who is going to talk about deploying with Docker. I just closed the web browser, but I think that's right. So a big applause. Round of applause.
Thank you. I hope you're having an excellent morning and an amazing PyCon so far. My talk's going to be about Docker, because we don't have enough of those. It's not necessarily going to be about the best way to use Docker in Python. It's just about one way that we found, sort of stumbled through, like in the dark before. Now everyone has like this nice, amazing framework for deploying with Docker. But this is sort of more a wild approach, if you will. Before we get into the details, I'm just sort of going to describe like what we were doing before we were using containers. And we had like, before also I get into that, we had a lot of incidental complexity. I'm going to describe what we were doing. And it's not necessarily always wrong, but the way we were doing it is wrong. And that's caused a lot of problems. But there were also some inherent problems with it that were fixed once we moved to containers. So first, we were actually using Debian packaging. And if you've used it, I mean, it's nice. It's used for, I mean, it's made for Debian, right? So you have like an upstream package. You want to maybe apply some patches. You wait for it to stabilize, and then you ship it to users like 3 to 4 years after the upstream release, right? So that really doesn't work if you're trying to do continuous delivery. And there's also like, Debian packaging is not very like that simple, right? It's quite advanced. So if you don't actually know what you're doing, you can get into a lot of trouble. You can get into dependency conflicts. You can like accidentally uninstall stuff. Like all those things happen to us. And it's mostly because we didn't know how to use Debian. But I mean, it's still like you don't want to be like a Debian expert, right? It's set up to make the maintainer suffer and not the end user. But in this case, like I'm the maintainer, so I don't really want to suffer. So that's another reason to sort of move away from that. And then we were using Puppet for configuration. And if you haven't used Puppet, it's basically a system where you just say how you want, like the things you want to happen to your machine. And then Puppet just like applies and runs it all for you. And you can use it on like a fleet of machines. But the only problem is that it's not, you don't describe the state of the machine, you describe the things you want to do to it. So for example, if you install a package and then you later remove the directive to install the package, it doesn't actually remove it. You have to actually put a directive to ensure to purge the package. And so if you're in this situation and then you spawn a new machine, it's actually going to be different from your older machines. So immediately you're denormalized and you might not even know it, and that can lead to a lot of headaches. Plus, you have to sync it with your Debian package, right? So you have your configuration in Puppet, and you have the code that uses it. So if new code requires a new configuration, you have to make sure it's in sync. Otherwise, like your deploy is going to fail because it can't find the new configuration. And that's a pain in the ass because it's also like a separate repository, right? So if you want to revert, you have to make sure you revert in both places. It's not a lot of fun. And again, you need expert Puppet knowledge if you really want to make it work very well. So now you have to be a Debian expert and a Puppet expert and a Python expert and an expert on the domain which you're working. And like really, I'd rather not be an expert on anything. I'm just trying to make my job obsolete so I can just drink coffee and read Hacker News. And the next thing we're using is Hermes Broker. So Hermes is this RPC protocol we have at Spotify. There's really nothing wrong with this. I'm only describing it here because of some issues later on. So what it does basically is it receives the messages and then it distributes them locally over multiple ports. And the reason for that is we don't actually get enough performance out of one process in Python. So we need to spawn multiple instances. And the Hermes Broker just distributes load among them. And it has like an internal queue. So if you're restarting and one of them is down, it sort of puts things in the queue, and then when it's back up, the message will be delivered. So you don't have to worry about like rolling restarts and so on. And so now it goes to the deploy process. This was actually the most painful part. So first you have to upload the package, which isn't actually so bad. But you have to make sure that happens. Usually it happens from the build server. But if there was a problem with that and it didn't happen, and then you go on and you like deploy, and you test, and your changes aren't there, and you look stupid. So you want to make sure that your package has actually been uploaded correctly. And the next step is cluster SSH, which is my favorite. And if you don't know cluster SSH, what it does is it's like you give it a list of host names, and it spawns a bunch of terminals to each with like an SSH session to each of them. And when you type, it just like broadcasts the input to all the panes. So it looks kind of scary with all the stuff going on. But I mean, it's a serious anti-pattern, right? Like you don't want to be doing that as like that's your deploy. Because, I mean, come on. And the worst part is you end up looking like this guy, right? You can't really see him, but that's Cypher. And like that's the worst. Like nobody wants to be him. So yeah, and the next, so you want to do like apt-get install, puppet apply, make sure everything is nice. Sometimes you get problems here if you messed up your Debian package, if you messed up your puppet manifest, or if they're just not like totally in sync. Like you can get into like certain issues, and if you're just testing out a change, you might have like had to put a puppet branch for your changes first. So you need to denormalize the machine, make sure it's running on the branch that has the correct changes, and then you apply. So it's a bit involved, and like as you can imagine, like very, very error prone. And this is assuming none of the machines are denormalized, because sometimes you do apt-get install, it works on all of them except one or two where it fails for whatever reason. There's always an issue, right? So next, you want to restart the service. Supervision is like a supervisor we use to make sure you just tell it you want n instances of your service, and it makes sure they're always running unless you specifically tell it to stop them. So here we just tell it to restart, and we tail the logs to make sure nothing went wrong. Yeah, and as for what could go wrong, I mean, you just take your pick, right? We already talked about configuration mismatch, denormalized machines, and if something does go wrong, rolling back is really, really hard, because if you had like a configuration change, you need to make sure to roll that back as well, and you need to get the right package. And sometimes, depending on how you wrote your Puppet manifest, you can't really roll back, because now you need to figure out whatever else you broke and fix that. You can also have network issues. So you're doing cluster SSH to, to 20 machines or so. To 3 or 4 of them or whatever, you might have like a network problem, and then the connection fails. And if you don't notice, then you just didn't deploy to those nodes, and you don't know. So that's not good. And when you have so many manual steps, like you can imagine there's a lot of human error involved. So now this is where Docker comes in, right? And I kind of want to like just say, I'm not necessarily saying it's better than like everything else that you can use. I'm just implying that it's better than everything else you can use. And if you're not familiar, you can do like a quick Docker 101. So basically, it's a layer on top of LXC, or Linux containers, which are just isolated processes that have or that think they have their own file system, their own network stack, and they're just isolated from other processes. So it's kind of like a lightweight VM, but like especially for the purposes of just like a simple service, all you want is the isolation. So it works just as well as a VM would, but it's a lot cheaper. So you have a Docker file. And Docker file is a list of commands for building your image. So you would like copy stuff into it. You want to run apt-get install to install dependencies. You want to run pip install to install dependencies. Maybe you create symlinks or whatever else you need. And each of those commands is a layer in the container. And the layers are cacheable. And what this means is basically if you have, let's say you have 10 commands, and if you only change the last command, then you don't need to rebuild the whole image. And that also applies for when you're pushing it to a repository. You don't need to upload the whole image. So this is really nice because like your image is going to have like the base operating system and so on. So it's going to be quite large. But if you're only making a configuration change, then you only push a very small layer to your repository, and you only have to pull a very small layer on all the machines where you need to deploy. So it's quite fast. And as to the parenting, it's you can have like inherit from like a base Ubuntu image, for example. So then you have Docker build, which will build your image. It's quite simple. And Docker run to run it, to run a container based on a given image. And this takes quite a few parameters. We're not going to go into all of them, but you can also just run it locally on your machine, which is like the prime advantage. And configuration is done via environment variables that you pass to the run command. This is because all your image is like static, so all of your containers will run the same image, but you still want some things to be configurable, right? If you have connect to different database machines and so on, so you will do that via environment variables. And then you use Docker push to push your repository, or push your image to the repository, and Docker pull to pull it from the repository. So you push from either your build server or your local machine, and you pull from all the servers. So immediately we get actually quite a few benefits, right? So the first and the most obvious is the code and configuration are always in sync, and they're in the same repository. So if you make it, you don't have to sort of synchronize two different code reviews. And if you want to revert, you revert everything that's actually involved. You never have to, or you never end up forgetting that there was a configuration change, and then you end up with problems later down the line. So that's really nice. And you get reproducible deploys, because now your deploy is just Docker run, literally. And if you run the same image with the same parameters, then it's the same input, so you should get the same output. So it's as reproducible as it gets. It's really quite reliable. And rolling back is easy, right? Because it's the same thing, really, as deploying, except instead of deploying the latest version, you're just deploying the previous version. And the same goes for like your personal build. If you want to make a change and just test it out, you can push your personal build and deploy that, and it just works. You don't have to worry about, like the different stable, unstable package versions, pinning, all of that is just gone. Testing becomes a whole lot easier, because now you can run the image on your own machine. As long as you have Docker, you can run any Docker image. So you don't have to worry about like, oh, I'm running Debian or I'm running Arch Linux or whatever. It just works for you. And not only that, if you're trying to set up like automated testing for like a testing environment, you can spin up the exact same container every time. And you can even, instead of mocking external services, you can just spawn all the services that you need in your little test environment and make sure everything works, like assuming, of course, they have Docker images. And this is another nice thing, is that you don't need Puppet manifests anymore. Like Puppet manifests aren't this like bad, but that's one less thing to worry about. Now you only have to worry about your code and your configuration, which are in the same repository, and that's all the information anyone needs to know about your service. And this is quite a useful benefit, migration. We were migrating from Debian to Ubuntu. And this makes it a lot easier, because if you can build your service into, let's say, like a Debian image, the Debian Docker image, then you could run that on Ubuntu or anywhere that Docker runs. You don't need to actually port all of your dependencies or make sure that everything works in the new operating system. You just make sure it works inside of Docker, and then you can run it anywhere that you can run Docker. So how do we actually deploy? Well, we use Fabric. And I know the first question you have is, why didn't you use Fabric previously with all that crazy clusterization stuff? Well, actually we did, but so many different things could go wrong that we always had to supervise it anyway. So we sometimes used Fabric, but mostly we used cluster.Sh because we had like more significant changes. And the other question is, why not use like another orchestration system? Like at Spotify, we have Helios, which is open source. And at the time that we were doing this, Helios was still early in development. And we actually do a lot of things that aren't supported by Helios or Kubernetes or any other system. I mean, if there's a system that supports them, I would like to know, so I don't have to maintain this anymore. But I couldn't find one at the time. So one of the first things you want to work on is logging. You want to know what's happening with your service. And Docker has a command called Docker logs, and you just give it a container, and it shows you, just dumps all the output from that container. And this command sucks. I mean, it's the worst. It just dumps all the output. There are no timestamps. I mean, you can follow, but it's only there in case you haven't set up like robust logging and you just want to have an idea. But you should never use it in production. On top of that, we have like a log delivery system to Hadoop. So logs are expected to be in certain places in the file system. So what we ended up doing, and this worked nicely for us, is because our code set up logging by using devlog. We would just mount devlog into the container. And that works. It's the easiest thing ever. What else you can do is connect to the actual syslog daemon on the Docker host and set it up that way. So it depends on how you're setting up your logging, but if you use devlog, you can just mount devlog. Super easy. Next, service discovery. As I mentioned earlier, the Hermes broker, or did I mention that? That one would actually handle the registering for service discovery, so know where to find your service. Since we're not using that anymore, we need to do something else. And the problem is you need to know which ports you're listening on, right? And now we want to spawn X containers. We don't want to be limited to a specific fixed amount. If we find that there's a performance problem, we want to spawn like 10 more containers and see if that helps. And if we do that, we no longer have fixed ports. But we need to know the ports. Docker has a feature that allows you to set like dynamic ports. It finds a free port for you and associates it with your container. The only problem is now you need to find what that port is in order to register. And that's a bit of a pain in the ass. So what we do instead is we just like take a port, assume we can use it, and if it works, like everything is nice. And if it doesn't, we just try again with a different port number. And you'll see later when I show the actual script. And for persistence, we don't really use it much. Our services are stateless, but we do run RabbitMQ and Redis. And for those, it's a simple matter of mounting, because Docker allows you to mount a volume from the host into the container. So you can just mount a volume from the host into the container, and those files will be persisted. Next, secrets, because you don't put like your passwords in the repository, right? Because we never do that, certainly. So you don't want that. So what we have a Puppet secrets repository. And it sort of does host-based authentication. So if you try to fetch a given secret, you will only receive it if your host matches certain criteria. So either if it's in the correct environment, has the proper role, and so on. So since deploy scripts can run commands on the machine, we can just attempt to request the secret. And if we're allowed to see it, we'll see it. So you can try to deploy to a machine that's not allowed to see the secret, and it'll just not have that configuration value. And the nice part is you can also have different secrets in different environments. Like your testing environment can have different credentials for like a separate testing account. And resilience, like with supervision, it works really, really hard to make sure your service is always running. So you don't want like your service to stop running, because the service never crashes normally, right? Because it has no bugs. But sometimes it does. So in that scenario, you really want it to keep going. And since I think 1.3, Docker has a feature called restart on, I believe. So you can tell it to restart your service if it fails. And that one works quite nice, except we had an instance in our service where it would catch an exception, not say anything, and then return with status code 0, which is not very nice. And then Docker would just be like, oh, OK, just exit it, and it stops running. So we come back the next day, and there's nothing running. It kind of makes us look stupid. So you want to make sure that the restart policy that you choose actually works for your service. Yeah, I think we can actually move on to some of the code. I don't know if you can really see it that well. So this is from a Fabric script. So first, we just pull the image. So this will make sure we have the version available. Next, you see there's a loop over a port range. And this is what I mentioned earlier, that we don't know which ports are available. So we just try until we succeed. And here we're passing some parameters. These are all environment variables that will be sent to the container. And what you want to make sure to do is always have default values for these, in your actual service. Because if you don't, then you must always do something like this before you can run it. And you can never just run it on your own local machine unless you're insane and can pass all these variables every time by hand. So you want to make sure you always have sane defaults. And in this case, what we're sending is the backend domain for service discovery. And again, the external port for service discovery. There's a secret. There's some just regular parameters. A Docker host is actually very, very useful. It's the IP from which you can connect to the actual bare metal host. Because if you do localhost, that will actually just go to your Docker container, because it has its own net stack. And most likely, you don't want that. You're trying to reach outside. And getting that can be tricky, The way we have it set up is we have a pre-configured bridge interface. So we can always fetch that as a fact when we launch the container. But you can also discover it from inside the container. There are different ways of doing it. And if you Google around, you'll find quite a few with different trade-offs. But having that is extremely useful. Then we just have some other configuration parameters. Next, we want to actually build the command that we use to run. So this is just a little helper, because fat fingers, you don't want to make typos in the command. So like the restart on failure flag, we have the image, like some parameters. Like I said, we mount devlog, and we use Docker links. And links are basically, if you have multiple containers, you want them to talk to each other, you can set up a link. And on the left side is the host name you want to have for the link in one container, and the other side is the actual container, a container name. So in this case, we want to be able to talk to RabbitMQ as RabbitMQ, as a host name. And if you go back here, you'll see that that's what it says for the URI for connecting to RabbitMQ. It's not an IP, it's just RabbitMQ as a host name. And Docker will translate that into the right container's IP. And yeah, and next we just check to see how it went, right? So if the address was already, or the port was already allocated or used, then we just try the next one. And if something else went wrong, then we actually want to abort. And then you see like an unexpected error, and then you can fix whatever went wrong with the deploy. Next we have, like I mentioned, we want to run multiple instances. So we just make sure we spawned enough instances to match what we were trying to do. And the reason like this port code is really useful is because if you're shutting down a previous instance, you don't want to remove it immediately, because there will still be clients sending requests to it. So what you do is you first send a sigquit, which tells it to remove itself from service discovery. But then you also give it like 10-minute grace period for any clients that were still sending requests. So the previous instance was most likely still running at the old port. So you just have to keep trying until you find a free port every time. And for the future, the bright future, these scripts aren't actually super reliable, because it's still like a Fabric script that runs commands on a host. So if there's a slight difference on the host from what you expected when you wrote the script, it will fail. Network weather will make it fail. There's a lot of things that can go wrong. And ideally, you want a system where you just describe what you want to have. So you say you want this container and instances of this container with this configuration, and you just want that to happen. How it actually happens, you don't want to write the actual Docker commands. So that's what like the most Docker orchestration systems do currently. But they don't handle everything well. They might not handle the way we launch multiple instances, or links, or other configuration flags. But what we're looking at right now is trying to find one that actually fits us best and use that one instead. Because while this is like a very, very nice way of actually learning how it works and understanding what's going on with your system, it might not be the best long-term solution for deploying. And actually, that's it for me. So do you have any questions?
Why did you switch from Debian to Ubuntu?
That's a different story. I think there's a post somewhere about it. It was a while ago, but yeah, I was not involved in that. I think it was even on Hacker News, maybe, but you'll find it if you look.
Hi. You're making quite a lot of work to forward TCP IP ports into the container and out of it. Why aren't you just exporting a Unix socket into the container?
But well, you mean like the Docker?
Yeah.
Yeah, because then you're sort of tied to Docker. And the thing is, we didn't even really know how Docker worked at the time. So it was easiest to just avoid making changes to the service itself. So the way we have it now, the server is just, like that's also why we mount devlog, because then it's the same code we had previously. So it's just actually less work for us given what we know.
You said that you had migrated to Docker. How much of your operations today is Docker-based, would you say?
So this is just for one squad, and we actually moved all of our services to Docker. But there are actually lots and lots of backend services, and some of them are using Helios, and some of them might just be using Docker, but I can't speak for everyone.
So, since this is a Python conference, what is Python specific about your deployment here?
It's the fact that we actually couldn't find anything suitable for the way we actually run Python services. So, for instance, the way we run multiple processes, like or multiple instances, like none of the things that we looked at the time, which was like a year ago or so, a year and a half ago, none of them actually supported this use case. And we have Spotify, like Helios internally. We actually went to the Helios guys, and they're like, yeah, we can't really help you here. You should just use Java. But yeah, let's not get into that.
Hi, Ziad from Rackspace. We actually do a lot of this similar work at Rackspace. We've been using, we're looking at a lot of Docker Compose, which is written in Python. And we've been using Fleet to have services be running on different machines for a certain level of high availability. I didn't see anything here on how you make sure, like, for example, not all your Rabbit containers are on one host. How do you do that?
So the way we do that is the script has a certain quota of instances that it fills per host, and you just give it a bunch of hosts. And I didn't show how we actually determined that. But we have like a hardware set aside for this, and then we just say, hey, take these 20 hosts and use them for your deploy. So it's actually not, we don't have, like for this, we don't have a general pool of hosts available. That's actually part of why we want to move to something like Helios, because then you can just stop worrying about the actual hardware.
How much time did it take to migrate from packages to Docker?
It actually didn't take that much time. Like the initial, like getting just to run, maybe a couple of days. But fixing all the issues that cropped up, like making sure logging works reliably, making sure service discovery, and making sure, especially that when you deploy, you don't actually lose any messages because you've removed the old instance and so on. Those things took a while to stabilize.
And one follow-up question, did it have any difference in, you said that when you use cluster SSH, sometimes you might have instances that are not, that the connection, the SSH connection has failed, for instance. Does Docker mitigate that problem, or was it a problem that was solved in another way?
No, that's, as I said, not all the problems were like inherent to the systems or related or solvable necessarily by Docker. So that's one of those issues that is just like a general problem. But the reason why it's somewhat related is because we could automate it, but only if we get more reliable results. Like I said, we tried automating it before, but then because of the normalized machines and so on, you can't assume that every failure is a network failure, so you can't just retry. So you have to actually manually check what went wrong. But now that we're fairly certain that every deploy is the same, if it fails, we just retry it. Nothing? All right. Thank you very much.